So I'm going to quickly add, so if you're keeping a reference sheet, which obviously I would recommend, especially because it's going to be at least a week and a half before we see this again, the parabola formulas for let's start with our horizontal, no, let's start with our vertical one because that's the one we're most familiar with. Our vertical, which means it points up, it has a positive 4p, it points up, or a negative 4p, it points down. For this, our equation is x minus h squared equals 4py minus k. And that hk can be 0, 0, which would eliminate the h and the k, or it can actually have a vertex in which you would keep those values. Remember, p is the distance from the focus, or the vertex to the focus, and the vertex to the directrix. So if it opens up or down, you've got your vertex, you've got your focus, which would be a coordinate point, and you've got your directrix, which would be a y equals. And they are each p distance away. So from vertex to focus, p distance. From vertex to directrix, p. Then you had your horizontal, where if it's a positive 4p, it opens to the right. And if it's a negative 4p, it opens to the left. And these are your y. So y minus k squared equals 4px minus h. Same thing here. The p is the distance from the vertex to the focus and the vertex to the directrix. The difference is when you turn your parabola to the side, your focus would be inside and your directrix would be outside, which would now be a vertical line, or an x equals a number. Yep.
You can tell the direction or the orientation based on the directrix?
Yeah, sure.
So if it's an x equals, that means it's to the side?
Correct. But you don't know if it's right or left.
Yeah.
You have to have one other piece of information.
That's the sign on the P.
Yeah, or it could be a focus, or it could be a vertex.
So if it says the directrix is x equals 1, and it says your vertex is the origin, what would it be?
P is 1. If directrix is x equals 1,
I know that was one of my
and the vertex is at 0, it has to point away from your directrix. It can't cross through it. So that would be a y squared with a negative 4p. So it would be negative 4. Okay, so now we're going to add to these because we're going to talk about ellipses. Ellipses are ovals, okay? By definition, an ellipse is the set of all points x, y in a plane. The sum of whose distance from two distinct fixed points, are called the foci, is constant. So this is a horizontal ellipse. This is wider than it is tall. You're going to get both. The end points of the longer axis, which we'll learn in a second or review, is called a major axis, would be your vertices. The end points of the shorter axis, which is called the minor axis, are called co-vertices. So this co-vertex, there are two of each. The center is at the middle, so instead of a vertex, it's a center. And then you have something called, you have two focuses, and the plural of focus is foci. And those lie on the same axis as your vertex. So individual would be called a focus. Plural is called foci. So all of that rotates if it's a vertical one. If it's a vertical one, your vertices are at the top and the bottom. Your co-vertices are left and right. Your foci are at the top and the bottom also. The focus is always inside, okay? So that flips when we get to hyperbolas. The focus is always inside the oval or the ellipse. Yeah.
Remember the reference sheet that we had last year?
Yeah.
We used. Do you think you could post that? So
Sure.
remember?
Sure. Yeah.
Do they have a directrix as well?
No. Parabola is the only one with that. Okay. So some vocab. The line through the foci, again, plural of focus. So the line through the foci intersects the ellipse at 2 points. Those 2 points are called the vertices. So again, this is a horizontal one so that they're on the horizontal axis, which is called the major axis, which that's the next thing says. The chord joining the vertices is the major axis, and its midpoint is the center of the ellipse. The chord that is perpendicular to the major axis at the center is called the minor axis. That's the shorter one. Major, longer, minor, shorter.
Does it ever switch?
It will go vertical, but still the longer is always major and the shorter is always minor.
The X is still the major and the Y is still the minor?
No, not if it's vertical. If it's vertical, it will be taller than it is wide. So this will be the major and this will be the minor.
Okay, so
You'll see that. That's on the next slide too. Yeah.
Vertex is just the widest ones, always?
Yes.
Okay.
All right, so standard form of an ellipse, okay? Centered at 0, 0. If my center's at 0, 0, and it's a horizontal ellipse, then this is what we just looked at. Our vertices are right and left. Our co-vertices are up and down. Our foci are right and left. Major axis is the horizontal axis. Minor axis is the vertical axis. If you switch it and now you're looking at a vertical ellipse, now you're going the up and down to get the major axis. So you're going up to get the vertex, down to get the negative vertex. Up and down gets you your foci, right and left gets you your co-vertices. Yep.
Will we ever get ones that are like not centered?
Yes, we'll get to that today too.
So it's like slanted?
Oh, no, like rotated?
Yeah.
No, we're actually not going to do it. It's in 9.3. It's so fun to do. But I asked if we had to do it, and Farrier said no. I was like, you just made my day. It's called rotation of a conic, and it is not fun. Yeah,
So
we are not doing it.
Like, okay.
Mm-mm.
So only your major axis has foci.
Correct.
Okay.
So for both of these, A equals the distance, add this on, distance from the center to the vertices in both directions, either up and down or right and left. The B is the distance from the center to the co-vertices. And C is the distance from the center to the foci. Doesn't matter if it's vertical or horizontal, all three letters represent the same thing. All right, I'm going to jump to the bottom and then I'm going to jump back up because like kind of to piggyback up off of A, C, and B is the relationship between those three is C squared equals A squared minus B squared. So almost like your Pythagorean theorem, but it's got a minus between because the foci has to be smaller than your A. So the questions will always give you either two of those three or a way to find two of those three. And then you will use that C squared equals A squared minus B squared to find the third thing. Also on the bottom says the length of the major axis is 2A. That should make sense if I go, like, let's say it's horizontal, I go right and left A, then my major axis length is going to be 2A. That's one of the ways they'll say, they'll give you what A is. They'll say, like, the major axis is 20. So then you know A is 10. And the length of the minor axis is 2B.
So A, B, and C will never be negative?
What do you mean? Like each individual one?
What?
I don't, you asked me a question. I whatted your question. You can't what to your what question.
I don't understand.
A, B, and C individually will never be negative? Is that what you said?
Right.
Correct. Like each individual one is a distance.
Okay.
Is that what you mean?
So it's gonna be
Yeah.
So A, B, or C cannot be negative.
No, but I mean like in the equation, can it be negative?
Well, like if you plug in, let's say you plug in A and C and you go to solve it, it might be negative B squared equals, but it will equal a negative number. So it will always go back positive, if that's what you mean. You'll see that happen today. Yeah.
Go back to the previous
Mm-hmm.
one.
All right, so much like your parabola and your your parabola and your circles, there are two ways to write these formulas. The first is with a center at 0, 0. So if the center is at 0, 0, then there's nothing next to my x or my y in either of these, okay? In a moment, we're going to learn what happens if the if the center is not at 0, 0. So you can memorize both sets, but really as long as you memorize that second set, you can plug 0, 0 in to get to here. But here's what's important. Well, I mean, a lot of this is important. But the most important thing is that here and here, the order do not matter. So horizontal and vertical, it doesn't matter what comes first. X squared could come first or y squared could come first. What you're spotting and what you're looking for is which one has the bigger denominator. So A is the bigger denominator. A squared is the bigger denominator. If it is under the x squared, then it's a horizontal ellipse, which means wider than tall. If it is under the y squared, then it is vertical, taller than it is wide. Again, order does not matter. It matters for hyperbolas, if you remember that, but it does not matter for ellipses. Then every one of these gives you like a chart. Like if you want to memorize that if it's horizontal, then you're changing the x. So you're going up A and down A. And you're changing the x for the foci, up C and down C. And then for the covertices, you'd be changing the y, because you're going the opposite direction. So it'd be positive B and negative B. In my opinion, I almost always map it out. Like I almost always draw it, and then I don't have to memorize this chart. But if you are a chart person, okay, if you like this kind of visual, then have at it. The most important thing is that the horizontal for major axis, which is your x values, you would move the A's to find left and right to find your vertices, the C's left and right to find your foci, and the B's up and down to find your covertices. And that is reversed with vertical. With vertical, you're going up and down your A, so you're changing the Y's. You're going up and down the C, so you're changing the Y's. You're going right and left the B, so you're changing your X's. Okay. Again, I would recommend drawing it out. This is what happens if your center is not at 0, 0. So I would say if you're going to memorize one formula or one set of formulas, make them these, because you can always plug a 0 in and get back to the one before, but you have to remember what happens if your center is not at 0, 0. So x minus h squared over a squared plus y minus k squared over b squared equals 1. It has to equal 1 on all of these. And then vertical y minus k squared over a squared plus x minus h squared over b squared equals 1. Again, order doesn't matter, but the bigger denominator has to be under the x for horizontal and under the y for vertical.
When you say the biggest denominator, does that mean that your A is always going to be the biggest in your equation?
Correct.
Okay.
Yep, because think about it, c squared is a squared minus b squared, so a has to be the biggest.
So like, okay.
Yeah. Okay, so then again, if you want to do a chart, on the left-hand side, you're taking your x values and you're changing them, but the x is no longer at 0, so you have to take the h, add and subtract a, h, add and subtract c, and then for the covertices, you change the y, so k plus and minus b, and then reverse it for the vertical. If you do it visually, you don't need to memorize that chart. You just need to memorize formulas, and then you need to move. That's all. All right, example 1 says find the standard form of the equation of the ellipse having a foci at 0, 1, and 4, 1, and a major axis length of 6. So start with the first piece of information. Foci at 0, 4, or 0, 1, and 4, 1. So 0, 1 is one focus, and 1, 2, 3, 4, 1 is the other focus. What does that tell you about this ellipse? It's horizontal, and if it's horizontal, which one gets the A? The X gets the A. What else does it tell you?
Tells you where the center.
The center is not at 0, 0, right? The center is the midpoint of those two. So if you draw it out, you can spot it, like visually. That's my center. If you don't draw it out, you have to find the midpoint. So I would do 0 plus 4, which is 4 divided by 2, and then 1 plus 1, 2 divided by 2. Either way, you get 2, 1. That's your center. So already I can do x minus h squared plus y minus k squared equals 1. Now I just got to fill in my denominators. What else does your foci tell you? The major axis, which makes it horizontal, what value does it give you, A, B, or C? C. Foci, like think foci has a C in it. Foci is C. So C is the distance from the center to the foci, which tells you in this case C would be what?
2.
C is 2. I got all that information from just having the foci. Then the second piece of information, it says the major axis length of 6. What does that tell you?
2A equals 6.
Good. And if 2A equals 6, then A equals 3. So now I have a denominator to go under the x because it would be 3 squared, which is 9. And again, it will always give you enough information to get 2 of the a, b, c, and then you will use the formula c squared equals a squared minus b squared to get the third piece. So c squared is 2 squared, a squared is 3 squared, and I get 4 equals 9 minus b squared. Negative b squared equals negative 5, so b squared equals 5. Now, it didn't say I had to graph it, so I don't have to square root that because in my equation, my b is squared. So I literally just put the 5 under the y. If I was to graph that, I'd approximate it. Like it's square root of 5 is a little bit bigger than square root of 4, so it'd be like 2.1. And then you have your a, you have your b, and you could graph your ellipse.
For your major axis length of 6, why'd you do 2a?
Because major axis is 2a, minor axis is 2b.
Oh, okay.
What did you get the C?
I did, the c was the distance from the center to the foci. So from 2, 1 to either of the foci,
Yeah.
you're going to the right 2 or to the left 2.
Okay. And also, you can get your center from finding the midpoint of any of those. Like,
Correct.
the
If it gives you the vertices, if it gives you the co-vertices, it gives you the foci, the center is always the midpoint between that pair.
Wait, how do you get the 1 at the end? Like the-
Your standard form always equals 1.
Oh, okay.
So ellipses have to equal 1. Always. Yep. Questions? Yeah.
How do you get a equals 3? You would just,
They told you the major axis was 6. So if the major axis is 6, major axis equals 2a. 2a equals 6, a equals 3.
oh, okay, so you don't need to like use any other ones. Just-
Nope. All right. All right. Now it says sketch the ellipse given by the following equation. Verify the center and the vertices. What has to be true about an ellipse standard equation?
It has to equal 1.
Good. So does this equal 1? No. What would you have to do to get it to equal 1? Divide by 36. That would make a mess. X squared over 9 plus y squared over 36 equals 1 is the standard form of the ellipse. So it is vertical. How do you know it's vertical? The bigger is under the y. That bigger is which letter? A squared, right? So 36 is a squared, which means a is 6. What else do you know?
The major axis is 12.
Yes, but you don't need that to graph it. But yes, that's right. It's usually given the other way around. B squared is what?
3.
B is 3 because b squared is 9. You're right. And then what else do you know from your equation? It's like the first thing you should read, and it's like usually the last thing everybody realizes. The center is 0, 0 because there's nothing after the x and there's nothing after the y. All right, so now we plot. Center at 0, 0. A is 6 and it's vertical, so we go up 6. That's one vertex. We go down 6. That's the other vertex. So my vertices are 0, 6, and 0, negative 6. Then I go right and left, B, to get the co-vertices, which gives me co-vertices at negative 3, 0, and 3, 0. And from there, you can draw your ellipse.
Do we need to know C?
It will ask you for C on some questions, but you don't have to use it to graph it. So you'll see, like, the next question asks you.
What would you use C for?
It'll, like, specifically say, what are the foci? And it will ask you for the coordinates of the foci.
Oh, the foci are the ones inside of it.
Correct, which is the C. So, like, if I did ask for foci here, I would do C squared equals A squared minus B squared. C squared would equal 27. C would equal 3 root 3 because it's the square root of 27. And if I wanted the coordinates, I'd add that, because it's vertical, I'd add it to the y of my center, which was 0. So the foci would be 0, and then you can usually do plus or minus 3 root 3, but it could have also just been 0, negative 3 root 3, and 0, positive 3 root 3.
On the homework, is there graphing?
Yeah.
How would we do like foci on the other side?
It won't ask you to graph the foci, it'll just give you a line that you have to type it in. Yeah.
If like it doesn't work, cause like my graph on the last one.
Then you do it by hand.
We do it.
Yeah, always. If it doesn't work, WebAssign gets glitchy. Do it by hand. You have to do it by hand anyways. I'd rather you do it that way.
It's because it didn't go out one.
Because it working.
Correct, it was wide.
Right, but it's not.
Yeah. Good? Okay. All right, example 3 says graph the ellipse and identify the center, vertices, and foci. What do we got to do with this guy?
You make it standard.
How do I make it standard? Complete the square. Not once, but twice. Yay! Right? Because you got the x squared and the x, the y squared and the y. So we're going to group it. X squared plus 6x plus y, 4y squared minus 8y. And we bump the 9 to the other side. So it's negative 9.
Oh, don't you have to take the 4 out?
Sure do. Got to take that 4 out. So the first one's going to stay. Take out the 4 and I get y squared minus 2y. And now I fill in those spaces. So 6 divided by 2 squared becomes good. 9, add it on the left, add it on the right. And then 2 divided by 2 squared becomes 1, add it here. Now before I add it to the right side, I have to multiply it by the 4 we took out. So the right side, negative 9, positive 9 cancel out, and then it's plus 4. So this whole side is 4. And on the left, I use the shortcut to factor. Square root the first, square root the last, take the sign from the middle, put it in parentheses and square it. Plus 4, square root the first, square root the last, take the sign from the middle, put it in parentheses and square it, equals 4. And the ellipse has to equal what? 1. So I divide everything by 4. So with a circle, you would not do that. Like with a circle, you would leave it set equal to whatever it is. A parabola doesn't have to equal 1, but an ellipse and then also hyperbolas, we'll do this next when we come back, all have to equal 1. So this is x plus 3 squared over 4 plus y minus 1 squared. And you can put it over 1. You don't need to. But if it helps you remember that that is what your base is on that one, then feel free to also keep the 1 there. Now, tell me what you know about this ellipse.
The A is 2.
Center, negative 3, 2. Negative 3, 1, sorry. A squared is 4, so A is 2. Maddie, what did you say?
It's horizontal.
It's horizontal because the bigger base is under the x. One more thing. B squared is 1, so B is 1. Now we go to our graph.
So your A determines if it's horizontal.
Correct. Whichever letter the bigger base is under. All right, so negative 3, 1. And we said it's horizontal, so we go right and left 2. Which makes my vertices negative 5, 1, and negative 1, 1. I go up and down B, which makes my co-vertices negative 3, 2, and negative 3, 0. And I can draw the ellipse. Now this time it said identify the center, the vertices, which usually include both vertices and co-vertices. Sometimes your WebAssign doesn't ask you for both. And the foci. So now we've got to find the foci. We said c squared equals a squared minus b squared. C squared would equal 4 minus 1. C squared would equal 3, and c would equal the square root of 3. And then which direction am I moving that c? Right and left. So I'm taking this x coordinate of my center and I'm subtracting root 3 from it and I'm adding root 3 to it. So if it wants it separated out, and I think it does on WebAssign, you would do -3 minus root 3, 1, and -3 plus root 3, 1. If this was like an open-ended on a quiz or a test, you can leave it as plus or minus. But on WebAssign, it will separate it out. Questions?
Wait, what'd you say to do? Like, for, like, estimate it to what?
If I was to graph it, you mean, I would estimate. So square root 3 is close to square root 4, but a little bit less. So it's going to be a little bit less than 2.
But if we don't graph it, just leave it exact?
Mm-hmm. Even if you graphed it on the line that it asks for the coordinates, you have to keep it exact.
Okay.
You would only estimate it when you go to graph it. We're good? Yes? Okay. You do this one because it's the same process. All right. After you complete the square, you should be here, right? So I grouped together the x's, grouped together the y's. You had to take out the 4. And you should get x minus 1 squared over 4 plus y plus 2 squared over 16 equals 1. Raise your hand if you're good to there. Okay, good. All right, so now tell me what you know about this ellipse.
Center is at
Ooh, 8 does not equal 4.
A equals 2.
Oh, a equals 4. Sorry. I thought you went here. A equals 4. A squared equals 16. A equals 4. B squared equals 4. So B equals 2. What else?
The center is
Isn't that bottom bigger a squared?
The bigger bottom. Yep.
You're so right.
1,2.
Center is 1, -2. And which direction?
vertical.
Vertical, because the larger one is under the y.
We got that.
Yep. So center, 1, -2. Up and down, 4. So my vertices are at 1, 2, and 1, -6. Right and left, 2. So my co-vertices are 3, -2, -1, -2. And then it asks for foci, so I have to find c. C squared equals a squared minus b squared. C squared is 12. C equals square root 12, which has to get reduced. So that's 2 root 3. And then I am adding and subtracting that from the y coordinate of my center. So my foci is keep the x and add and subtract 2 root 3 from the y. So my ellipse looks like this. If I were to graph the foci, I would go back to the square root of 12 part to estimate it. So that would be in between 3 and 4. I would go literally like just maybe 3.5 and put my point.
That looks like an egg.
Thank you. Thank you for your feedback. Questions on that one?
Wait, do we have to grab like
The foci, no. I mean, if it asks you to, you can, but it usually doesn't ask you to. All right, so the last thing is called eccentricity. And eccentricity is how rounded your ellipse is, okay? The variable you use for eccentricity is E. This is not natural base E. This is something different, okay? So it's not like E on your calculator. That is not eccentricity. It is found by putting C over A. That's like literally it. You get the C, you get the A, you make a fraction, you simplify. That is your eccentricity. It always has to be between 0 and 1 because C always has to be smaller than A. And the closer it is to 0, the more it looks like a circle. If you could think about like if it was 0, that would mean that your C would be the difference between A and B would be 0. So it would be a circle. The closer it is to 1, the flatter it is. So more like a pancake, okay? So on the WebAssign, like as part of the things, it'll say, what is your vertex? What is your foci? What is your eccentricity? You literally just put C over A. So if you went back to the last one that we just did, if we're looking at the one we just did, then what would be your eccentricity? C is 2 root 3, right? A is 4. So 2 root 3 over 4 would reduce to root 3 over 2. It is on the unit circle. Yeah. Questions? Yeah.
Was eccentricity part of last year too?
I don't remember actually.
It was.
It was?
Remember.
I don't remember.
Is that the same way?
Yeah.
All right, your homework is on WebAssign. But it is not on your to-do list yet for Canvas because it is more than 7 days out. So enjoy the panda for the next 3 days, 4 days. Happy Easter. And then it will magically appear on Monday, okay? You do have homework. And again, I will post the practice test. God bless you. This required practice test not, but strongly recommended.